few years ago, we started to hear about a cloud everywhere, all the time. Society is producing more and more digital data. We save it all into this mysterious cloud. It's in your laptop, it's in my phone, and now even TVs. It's actually great, very convenient. But as we continue our journey to a seamless world of AI and machine learning, we got a harsh reminder what the data really is. The data is this: millions of chips shipped across the world. The data is also this: the extensively mining of rare materials. The data is also electricity. A lot of electricity is needed to maintain a data storage center. For a huge data center, it consumes even more than some countries. Of course, this also comes with a lot of CO2 emissions. This winter, it will be a real problem. During the pandemic, TEDxEcublens campus was shut down for a few months. However, we only saved 30% of electricity. That's because computers were still running. We still needed to access our precious data. As a scientist, I question myself, what's the alternative for data storage? What are we going to do to face this challenge? Actually, we have an answer. It exists billions of years. Everyone here tonight is also an evidence for such technology. Yes, you get it right. It's DNA. The very DNA inside all of our cells. It contains only 0.3 to 2 micron in length of space. It contains all of information we needed to maintain or build an entire human being. DNA is encoded by 4 letters, A, T, C, G. Digital data is encoded by 2 symbols, 0 and 1. It's actually quite simple to convert back and forth between these 2. If we use ASIC code script, my name, Chan, C-H-A-N, can be converted and write down with this sequence of 0 and 1. By using the conversion I listed at the top, my name also can be written as a strand of DNA. Once I produce this DNA, as far as someone can read it, my name will not be forgotten anymore. Here is a comparison. If we use DNA to store the data, it will be 150,000 times more efficient compared to the data storage center in terms of size. Talking about electricity, it will be used 820,000 times less energy. Think about it. Someone may ask, what about duration? DNA can last for a long time or not? I think this picture can answer your question. It actually can last long time. So now we have a question. Can we really write information into the DNA easily like we type on the keyboard? The answer is positive. To write information into the DNA, there is a straightforward method: chemically synthesize. This is the typical machine for this job, called DNA synthesize. You press the DNA you want to have letter by letter into this machine. In 2 hours, you got your DNA. This is an advanced version. It minimizes the same machine into a small volume and reach a high throughput. With new platform, we can produce more than a million of DNA in an hour. With recent and advanced technology, not only DNA, but other chemical groups also can be used to encode the digital information. This opens the opportunity to further optimize and the innovation of the current data storage way. For instance, the writing speed, the readability, and the density of information. To recap, we have a solution which can be implemented. It's much smaller, can last a long time, and use less energy. There is only one thing is missing: reading. Can we read it? Can you download your DNA and read it as fast as silicon-based method? For this, I would like to introduce you a new technology. It's called nanopore sequencing. Nanopore is a tiny hole embedded into the lipid bilayer. If we allow the single-strand DNA to pass through these small holes, the different ATCG will give different electric signal. By reading this electric signal, we can know the sequence of DNA. It is a very fast method, and also no need for additional amplification or labeling. More importantly, it is electric readout, which means cheap and easy to be massively parallelized, which lead to a portable device. In principle, there is no limit for the reading length, and also can be adapted to read the other chemicals, like polymer. Here is one example we did in a lab. We convert the digital information into this DNA polymer hybrid structure. We engineer our nanopore to enable a reading of bit by bit. With this, we aim to encode and decode digital information at single molecule level. If this sounds a little bit like science fiction, listen to this. During the Montreux Jazz Festival, this song from Deep Purple has been converted to the DNA, then retrieved and played at the end of the festival. This is not the future of the music, but it may be the future of data storage.